All right, this is a very famous problem. This is called the birthday problem. Suppose there are 30 people in a room. What is the probability that at least 2 of them have the same birthday? Now, there are 2 ways to do this problem. So let's talk about our 30 people in the room, or let's talk about the outcomes that are possible. You could have no one that has the same birthday. We don't really have one person that has the same birthday, so semantics, we ignore the one. We could have 2 people that have the same birthday, 3 people, 4 people, 5 people, all the way up to 30. So to do this directly, we would have to find the probability that exactly 2 have the same birthday, or exactly 3, or exactly 4, all the way up to exactly 30. Notice the word or is in between there, so we'd have to find the individual probabilities and add them up, which means we'd have to find like 29 probabilities and add them up. Way too much fun. Well, remember, if you add up all the probabilities, what should you always get? Hopefully you said 1. So this sum here should add up to 100% or 1. Well, notice what wasn't highlighted was 0. So what we can do instead is we can find the probability that no one has the same birthday and subtract it from 100%. So let's find the probability that no 2 people in the room have the same birthday. Well, to do that, what we'll say is that the first person in the room could pick from any 365 days in the year out of 365. But then the next person can't pick the same day as the previous person, so they can only pick from 364 days out of 365. And then the third person, they can't pick the birthday of the people, 2 people before them, so 363 over 365. And then the fourth person, 362 over 365. Well, this happens for all 30 people in the room. So this happens 30 times. So the last person will have only down to 300 and let's see, 35. So 336. I know that looks weird, but if you count from 336 to 365, there's actually 30 numbers. Not, it appears to be 29, but it's actually 30. Just like if you count from 0 to 9, there's actually 10 numbers. So in red here is the probability that nobody has the same birthday. So to make it that the probability that at least 2 people have the same birthday, we find the complement, meaning we subtract from 1. So 1 minus that. Well, if we carefully put that in the calculator, by the way, there is a formula for the numerator, which we get to much later on. We get approximately, pausing the video, unpausing the video, we get approximately 0.7063, which is 70.63%. So in a room of 30 people, the probability that at least 2 have the same birthday is approximately 70.63%, which seems very high. And that's what makes this a very cool problem, is that it doesn't take a lot of people to have a high chance that 2 people in the room share the same birthday. But the big thing, theoretically, what we just did was that we found out what isn't there, took its complement, and then that gives us the probability that something is there. So the complement of at least 2 people have the same birthday is no one has the same birthday.